You've learned how transformers work and how to use them. Now we'll turn that into a clear plan for what comes next. By the end of this topic, you'll walk away with a realistic roadmap to keep growing, on your own and with confidence. Picture your progress as a four-layer pyramid. At the base are your ML and deep learning foundations, plus intuition for working with sequences. Above that sits your understanding of attention and transformer architecture. Then you added practical skills with Hugging Face, fine-tuning, and prompting. Finally, you explored real-world applications and limitations. That structure is now in place. From here, our focus shifts to the next phase: sustained, independent growth as a transformer practitioner. Now imagine two paths ahead. On the first, you bounce between random tutorials, collect disconnected tricks, and never feel truly confident. You stay busy studying, but progress stalls. On the second, you follow a roadmap. You revisit fundamentals, layer in transformer concepts, and choose projects that match your current level. Each step builds on the last. Over 3 to 6 months, that structure can carry you from dabbling to being noticeably stronger. Transformers rest on three main math roots. Linear algebra is the language of vectors and matrices. It explains how embeddings and attention behave as geometric operations. Probability and statistics give you tools to reason about uncertainty, prediction, and evaluation metrics. Light calculus, especially gradients, shows how models learn through gradient descent. You don't need formal proofs here. Aim for an intuitive feel using beginner-friendly resources, and everything you do with transformers later will feel far less mysterious. To really understand transformers, build your skills in layers. First, strengthen core ML habits: how you split data, detect overfitting, apply regularization, and evaluate models with metrics like accuracy and F1. Next, layer on neural network basics: perceptrons, activation functions, simple feed-forward networks, and an intuition for backpropagation. On top of that, learn CNNs for images and RNNs or LSTMs for sequences. Code-first beginner courses are ideal for walking through this progression in a structured way. Treat your coding toolkit as another set of layers that support each other. Python is the glue language. NumPy trains you to think in arrays and vectorized operations, which maps almost one-to-one to tensors in PyTorch or TensorFlow. Inside a deep learning framework, focus on essentials: tensors, autograd, and tiny feed-forward networks. Then build muscle memory. Run small experiments, train on toy datasets, log losses, visualize curves, and keep your work in notebooks under Git. Repetition here quietly compounds, and it pays off later when you handle larger transformer projects. The shift from beginner to intermediate is about moving from using transformers to really working with them. Beginners mostly rely on pre-built pipelines, clean benchmark datasets, and treat the model as a black box. Intermediate practitioners start rebuilding small components, preparing their own datasets, and reading configuration files and logs. The more of that inner machinery you touch, the more control and intuition you gain over how models behave. Intermediate projects should feel like climbing a staircase. First, build an end-to-end text classifier. Collect your own data, clean it, fine-tune a model, then examine where it fails. That gives you real intuition about the full pipeline. Next, create a tiny translation or summarization system using a pre-trained seek-to-seek model. Finally, develop a prompting toolkit, scripts or notebooks where you systematically compare prompts, log results, and capture what you learn in concise write-ups or readmes. When you read transformer papers, don't treat them like novels. Beginners often slog from page 1, get stuck on equations, and try to memorize every detail. Practitioners skim in layers looking for the story, what problem they're solving, what idea they propose, and what's actually new. They lean on diagrams, examples, and plain language explainers. Your aim is not to decode every symbol, it's to grab the core intuition and connect it to what you already know. Use a simple filtration system for papers. Start by skimming the abstract and introduction, then force yourself to write a single sentence. What's the core idea? Next, scan the figures and tables and ask, how does this relate to the transformer pieces I already understand? Only then dip into the methods section, just enough to map new components to familiar concepts. To finish, write down 2 or 3 concrete takeaways and, if possible, run a related model or code example. That closes the loop between theory and practice. Think of the next 6 months as 3 overlapping phases, each with one main focus. Early on, lean heavily into foundations, core math, deep learning basics, and essential tools. As your confidence grows, shift your main effort to projects where you implement and ship things. Later, dedicate more time to deeper theory, research habits, and community. Throughout, set a realistic weekly time budget and adjust it each month based on your results and energy. Months 1 and 2 are about building core muscles, math intuition, basic deep learning, and coding fluency. You'll practice linear algebra and probability, follow a beginner deep learning course, and code tiny models from scratch or with simple libraries. The milestone for this phase is being able to clearly explain how a simple neural network trains. Months 3 and 4 are about learning by building. Pick 1 or 2 concrete projects, like a sentiment classifier and a summarization tool, and commit to taking them fully end-to-end. As you work, lean into the Hugging Face ecosystem, tokenizers, datasets, the model hub, and training utilities. Anchor your practice with light research, 1 relevant paper or blog each month, focused on improving your fine-tuning, debugging, and metric interpretation. Months 5 and 6 are about taking the training wheels off. You're no longer just consuming content, you're recreating it. Implement a tiny self-attention layer or toy transformer. Then experiment with it until you understand every line. Pair that with slow, careful reading of 1 or 2 core papers, paying special attention to their methods and experiments. Finally, step into the community. File an issue, fix a piece of documentation, or add a small example. Those actions mark the shift to being an independent explorer. You now have a clear mental model of transformers, the math that supports them, and concrete projects to guide your growth. Choose a 3 to 6 month path, schedule steady weekly practice, and ship small things along the way. Connect each step to a real goal. It's consistent momentum, not perfection, that will make you a truly independent practitioner.